Thank you, Glenn, and thank you for the invitation. It's a joy to be here. I'm going to talk about culture. I'm going to talk about the way in which culture constructs mathematics in school classrooms. Before I do, I could make some very cheap remarks about the UK. No, sorry, not the UK, England.
England?
About England, yes. We have to separate England from the other constituent nations of the UK because their educational systems are different. And I could very cheaply say, if I take an epistemological perspective, there is no mathematics taught in English classrooms. It's cheap, but it's true. And that's as much as I'm going to say on England. My talk has changed constantly since I've arrived. There is no mathematics taught in England, so it's not worth talking about. I've spent the last 20 odd years being funded by various people, and I'm very grateful, to visit mathematics classrooms in different countries of Europe. Cotti yesterday mentioned that she came from Sept. She's probably the only person in the room who recognised the photograph. I spent a year on sabbatical in Sept, working with colleagues there. I know Budapest better than I know any other city in the world, including any city in this country. I have spent so many months looking in classrooms in Budapest. But I've also systematically visited Finland. I'll talk about Finland shortly. Flanders, Spain, and I have videotapes of lessons from all around the world. You may know, for example, that the TIMS video study, which was undertaken in the second part was undertaken in 1999, have released 28 videos from 7 different countries, which are worth looking at. They are subtitled, so it doesn't matter what language they're in, you can access them. So for me, it's been my essentially research life's work trying to understand how culture creates mathematics in different European nations. And the consequence of that is, I have learned, and this is where I would be most assertive, I have learned over these years that we are, in mathematics education research, located in a series of what I might describe very crudely as crass dichotomizations. To compare Confucian cultures with Socratic cultures is fundamentally nonsensical. Thomas Wong, for example, will describe China as being this nation of 56 different peoples, some of which are Confucian, some of which are not. Northwest China is fundamentally Islamic. How can we say that all China is a Confucian culture? We cannot. How can we say that all European culture is Socratic? We cannot. Even if we take a Weberian argument and distinguish between the Protestant North and the Catholic South, that's still too crude. So, reform versus traditional in mathematics education discourse is nonsensical. Student-centred versus teacher-centred. It's rubbish. What is important is not how we dichotomise classrooms, but how we come to understand the ways in which teachers and children together, as part of a cultural tradition, construct mathematical learning. And to say that teachers who tell are wrong, or that discovery learning is intrinsically wrong, misses the point. So that's the end of my little rantet. Others might emerge, but we'll see how it goes. Now, because of what Cotti said yesterday, I did declare at the end of yesterday's session I would show a short video clip. Well, since then I've rewritten the whole talk. I'm going to have several Hungarian video clips, but this is the one I promised. This is a grade 8 lesson on the teaching of linear equations. It's the second in a sequence, and the first lesson in the sequence was basically a set of, I'm thinking of a number, I multiply it by 3, I subtract 1, I get an answer of 11, what's my number? And the children engaging mentally and orally with straightforward linear equations with the unknown on one side. The second lesson starts somewhat differently.
Na, tehát akkor hol is tartottuk? Mi is volt annak a szövegesnek az egyenlete? Ugye, ha jól emlékszem, ott tartottunk, hogy fölírtuk, hogy 3x plusz 20 egyenlő 2x plusz 70, és még egyszer a szöveg az volt. Mindenkinek van papírja? Hogy két egymás utáni napon ugyanannyi krumplit hoztak az iskola konyhájára, az első napon 3 nap.
Okay, so at the end of the last lesson, she posed a problem for homework, and that was this question based on the delivery of potatoes to the school kitchen. Now, before I let that go on any further, I wouldn't like you to think that because this problem has this superficial real-world quality, that Hungarian teachers pay attention to the real world. They don't. This is, in the Dutch sense, a realistic problem. It's imaginably real to the children. It's not intended to model reality. It's meant to give them a scaffold. It's meant to facilitate their access to the mathematics that's about to come. The kids know this isn't a real-world problem. Everybody in the room knows it's not a real-world problem, but they're happy to play the game because they know that playing this particular game helps them access what are, at times, difficult mathematical ideas. Oops. And almost as an aside, I forget who mentioned it yesterday, somebody was talking about proof. I remember sitting in a class of 15-year-olds in Budapest, and they were doing some work on a Fibonacci-like sequence, and they got the standard result for the first n terms of Fibonacci being, was it next term minus 1, is that right? The sum? Yeah. Yes? And the teacher said to them, well, how do we prove this? And this class of 15-year-olds, quite confidently, just said, induction. Yeah. And did it. Now, culturally, mathematically, that to me seems very different from what I've experienced in England. But they were confident.
Nagyság érkezett, és még 2 darab 10 kilós, a második napon 2 nagyság, és még 2 darab 10 kilós, hány krumpli volt egy-egy nagyságban, ha tudjuk, hogy mindegyiknek ugyanannyi volt. Jó, még egy dolgot beszéltünk meg, hogy mivel mindig kezdeni a szöveges feladatot, illetve a saját érdekem, hogy azzal kezdjem, hogy az is fontos dolog, igen, de hogy megjelöljen, hogy az X mit jelent ez szerint van. Tehát az X-et valami módon lerögzítsem, hogy én most az egész utat, az osztály létszámát, vagy most éppen mit hívok annak. A nagyságban lévő nagyságban lévő krumplit hívom annak. Na és akkor, hogy működik ez a mérleggel? Tudjuk el?
Mondjuk azért elveszünk az egyik oldalról mínusz 2, amit az mind a két oldalról tudunk mindjárt.
Miért hívják ezt mérlegeltnek? Így van, tehát most lerajzoljuk ezt a helyzetet képzeletben. Itt a mérleg. Ugye azért hívják mérlegeltnek, mert jól demonstrálható, jól mutatható egy mérleggel. Van 3 nagyság. Kicsit rohadt nagyobb kell csinálni, mert tényleg jó nagyobbat csinálok. És 2 kicsi. Ugye? A másik oldalon van 2 nagyság és 2 kicsi. Na és akkor mit lehetek mindkét oldalra? Ugye egy mérleget, innen a neve, hogy a mérleget képzeletben magad elé. Gondolod, és na talán.
Szerintem azért hogy most mind a két oldalról, ennek két vizsgálatot, mert
mi a célunk mindig azt
az
hiszem?
egyik oldalról az X maradjon, a másik oldalról egész.
Így van, tehát az egyik
oldalról X
maradjon. Pontosan, ez a célunk, hogy addig eljussak, hogy az egyik oldalon legyen egy vár, és a másik oldalon meg megmutatja, hogy az mennyi. Igaz? Na tehát akkor mit tegyen? Na mérjük fel a helyzetet, jó? Na mit vegyük el?
2 kis hálókat.
két kis hálót. Ja? De hogy az egyensúly fennmaradjon, ezt a másik oldalon is meg kell vennem. Hát még nem állom túl vidáman. Ugye? András, most mit még? Vegyek el két nagy zsákot. De így is egyensúly maradt. Tehát ha mérlegből csak azt mondja, hogy mindig ugyanannyit vegyek el. És akkor megkaptuk, hogy egy nagy zsák az 4, 5 kis zsák, és akkor ugye 5. Vagyis hogy néz ez ki a gyakorlat? Tehát ez volt az elmélete, az elképzelése. Hogy néz ez ki most így egyenletekkel? Máté.
Sorry, I can't do anything about it now.
Igen, tehát egy ilyen feltejellel jelöljük azt, hogy mit is csinálok mindkét oldallal. Hogy elválasztam, de itt mindig jelzem, hogy mit csinálok mindkét oldallal. Na, akkor próbáljuk ezt követni még egyszer. Kivonom 20 kilós vagy vissza, mert innentől kezdve már csak vissza, mert... Na, akkor itt marad 50. Második lépésről mit tettünk? Afrika. Bevonjuk a két részek, akkor itt marad. Itt, és megkaptuk, hogy ez 50. Készek vagyunk. Mit tartozik még hozzá a megoldáshoz? Annak ellenőrzése, igen. Illetve az, hogy egy mondatban szöveggel választ adja, hogy hogyan kell ellenőrizni egy egyenletet. Aha, akkor X-et behelyettesítjük a... Ugye megnézzük, hogy a bal oldal az X helyére beírom, hogy 50, akkor 3-szor 50 plusz 20, mennyi az? 150 plusz a 170, jobb oldal, az is 170-nek, az 250, 70. Tehát valóban jól oldottuk meg az egyenletet.
Okay, in 5 minutes 25 seconds, she's posed the problem, she's formulated an algebraic equation, she's represented that equation on the board with the scales, systematically gone through it and checked it. Now, in the best part of 25 years of observing English mathematics classrooms, both as a teacher educator and as a researcher, I've never seen an English teacher. Now I confess, I've only ever looked in state schools, I've never been inside an independent school, but I have never seen an English teacher start the formal treatment of linear equations with the unknown on both sides. They have always started with the unknown on one, trying to teach children something on the board, formally, that children can already do in their heads. Because if I'm teaching linear equations to children, and they can't solve in their heads 3x plus 1 minus 3x plus 1 equals 13, why am I teaching them linear equations? So we see all these teachers spending inordinate amounts of time trying to teach children stuff they can already do. Here, and interestingly, whenever I see linear equations taught in European classrooms, whenever teachers start the formal treatment, the unknown is always on both sides, because it justifies their teaching it. They're teaching it because kids can no longer do it in their heads. They need something formal. What I think is also very interesting is that that video was recorded in about 2005 as part of my last projects. 10 years earlier, I saw a teacher in Budapest teach an introduction to linear equations, and the lesson was almost identical. The only difference was that particular teacher not only represented it iconically on the board and then shifted that iconic representation to a symbolic representation, he actually brought in the concrete scales as well. So he had bags on his scales in the way that his teacher drew them, but he still drew them. So it seems to me, if we're talking about culture, Hungarian teachers work within an accepted cultural norm. And one of the things I think that is problematic in this country, and apologies if this offends anybody, is that we are led to believe that teachers should work in ways that they find suitable for them. There is no collective pedagogy in this country. But actually I think that's a fundamental problem of the English-speaking world. Because when one moves into European classrooms, one becomes much more aware of collective pedagogies or collective traditions. So, what is culture then? It's a word we've been using for the last 3 days. And those are various sort of cultural scientists' perspectives, or various attempts to try and summarise these things fairly straightforwardly. And it seems to me that it is this sort of sense of collective mental programming. It is something that we as a group regard as important. What is right, what is appropriate, what is necessary for the cultural reproduction of our particular group. And in all cultures, learning, classrooms, teaching, all reflect the cultural norms of that group. And where learning is valued, you get a very different feel in the classroom from where learning isn't valued. And however we feel about it, whatever we say might be the solutions in this country, we in this country, as in much of the English-speaking world, live in anti-intellectual communities compared to many of our European neighbours. So why would I want to examine culture then? And particularly, why would I want to examine culture and mathematics? Well, first of all, the more we understand culture, the more we can understand why, for example, certain cultural groups seem to do so much better than we do. And we're all aware, for example, in international tests, that many of the Pacific Rim states, or in those terms, perform very highly. I can also offer lots of cultural arguments as to why we shouldn't pay any attention to Singapore, even though Singapore does very well. But I'm not going to spend time on that now. Importantly, a cultural analysis of what goes on elsewhere helps me understand much better what's going on in my classrooms. It helps expose taken for granted assumptions about the nature of classrooms, the nature of learning. And a classic example, I have to confess, of English education is an obsession with school uniforms. In all my years of visiting classrooms in Europe, I've never seen a school uniform. And yet we have all the rhetoric over here that it has this wonderful contributory factor to learning. Kids cannot possibly learn if they don't wear uniforms. And then that leads to what I think is a really interesting cultural phenomenon, which is, I think, partly almost uniquely English. In England, we expect them to come into the classroom and conform by all wearing the same clothes, and then treat them all differently through obsessive differentiation. I look in the Hungarian classroom, I look in any other classroom I've visited, I see children who wear what they like, so there is no expectation of dress code conformity, but once they're in the classroom, they're part of a collective. And it's that collective that has responsibility for the learning of all, not just the individual. Huge different cultural norms. So I'm going to look at what I would describe an educationally cultural enigma. Finland, we know, from various, well, we have 4 iterations of PISA published so far. The 5th one is currently being undertaken. And we can see across the 3 domains of PISA how Finland has ranked on those various tests. So we can see, for example, in terms of literacy, it's been particularly successful, mathematically it's been quite successful, and the received view is that amongst European nations, the Finns have performed most highly. And such has been the international interest In fact, more than 200 envoys have visited Helsinki, even from Japan, to try and find out what's going on. Well, what do the Finns say? Well, the Finns say, and I think very rightly and with great pride, the Finns will argue that their comprehensive system is a huge contributor to the success of their nation. There is effectively no independent sector in Finland. All children go to their local school. Those schools are well resourced. But fundamentally, it is unlawful in Finland to group children by ability. So where in this country we have this obsessive desire to differentiate, the Finns do not differentiate by ability. They teach mixed ability groups constantly. But then that's not unique to Finland. Many other European systems would expect the same. And it would all, you can argue, for example, it's written in the constitution, written in the French constitution, about egalitarianism. Interestingly, the right to choose their schools has had no influence on Finnish parents' decisions. What else can I say? The Finns have an integrated special needs policy. No lengthy process of writing statements to warrant a decision. If a teacher has concerns are aired, and integrated special education needs support is immediate, all in the classroom. Kids are not removed, there's no stigma associated with it, and it's focused on mother tongue and mathematics. Teaching is popular, incredibly competitive. Teachers are held in high esteem. So, on the basis of those sorts of things, it would seem as though Finland may have something to offer in terms of learning how we might teach better. So let's have a look at a clip of a Finnish lesson. This is grade 4 lesson on percentages. It's the introduction to that lesson. So let's see how this plays out. Sorry, my wife's laptop.
voi olla myöskin 1%.
Varsinaisesti ennustaa yksi sadasosa on mennyt niin kuin valitukseen niitä prosentilla.
Now, I'm not going to spend time critiquing it. The first thing you notice is it's very quiet. Finished lessons, at least all the videotapes I've got of finished lessons, are always quiet. Children seem very passive. Even when asked to respond to questions, the answers tend to be fairly short. But what is most interesting for me is the teacher's response to the children's answers is, and this is by no means unusual, the teacher's response to children's answers is yes. Now we had a series of answers here, some of which were nonsensical, some of which were impenetrable, some of which were right. You know, we had a range of children's suggestions, and yet his response to all of them was the same. Always yes. When Salah wrote her equation on the board, he said thank you and moved on. No discussion of the equation, no drawing from the class what the equation might mean. So what seems to me to be part of Finnish mathematics classroom culture, and this has been based on repeated viewings of, I think, 30 videos from teachers defined locally as effective, it's an implicit mathematical learning culture. Children are encouraged to make extensive notes, and children are, it seems to be, left to infer what's going on. So, at what cost is Finnish PISA success? Well, according to academic mathematicians, recent curriculum reforms have stripped away logical thinking, elegance, structure and proof. Despite their success on PISA, Finnish success on TIMSS, the only one in which they participated, was...
Can you help those of us who aren't in the industry with some of these acronyms?
Sorry, okay. PISA is the Programme of International Student Assessment. It's managed by the Organisation for Economic Cooperation and Development, and it typically, when it happens every 3 years, they assess what they describe as children's ability to apply mathematical knowledge, scientific knowledge and literacy to real-world problems. They call it mathematical literacy, scientific literacy and literacy. TIMSS is a straightforward international test of mathematical competence. And the problems are not necessarily contextualised in any way. They could just be, solve this equation, perform this addition.
How are the children selected? I mean, you can't go around and asking everybody, so...
They are all, every participating educational system is obliged to satisfy certain sampling requirements with respect to getting a representative sample of that country's population. And where a school, say for example a school that is invited refuses, then they have to find a replacement. So there are very sophisticated replacement strategies to deal with schools who refuse to participate. The UK typically has struggled to get schools